Welcome to The Explainer. Today, we're getting under the hood of a machine that, let's be honest, powers pretty much everything in our world, the internal combustion engine. It's in your car, it's in boats, maybe even your lawnmower. But how does it actually work? All right, let's find out. So at its very core, an engine is all about solving one really fascinating puzzle. How do you take the chemical energy that's locked inside a little splash of gasoline and turn it into the raw force that spins wheels? It's kind of like modern-day alchemy, really. And the big secret? Well, it's right there in the name. Internal combustion. This just means the fire, the explosion, happens inside the engine itself. You know, unlike an old steam train that burns coal on the outside to boil water, this machine contains the bang right inside its moving parts. Okay, so to really get how this all works, we've got to start with the basic idea. It all comes down to harnessing a tiny, very controlled explosion, and then turning that explosive force into something useful. And this is our stage. It's a simple, single-cylinder engine, and what's wild is that even the most powerful V8 or V12 engines are really just a bunch of these basic units, all working together in perfect, roaring harmony. Now, to pull this whole thing off, you need a few key players. So let's think of them as the cast of characters in this little mechanical drama, where each one has a super specific job to do. First up, we've got the cylinder and the piston. I mean, this is the main duo, right? This is where all the action happens. The cylinder is the chamber, and the piston is our main actor, the one that moves up and down inside it. The piston's job is simple, but it is absolutely crucial. It is designed to get pushed hard. When that fuel and air mixture explodes in the cylinder, the incredible pressure slams the piston downwards. It's the part that literally catches all the energy from that bang. So a piston just bobbing up and down, that's not going to power a car, right? We need to turn that straight line motion into rotation. And that's where our next character comes in. And honestly, it's the most clever part of this whole machine. The crankshaft performs a little bit of mechanical magic. Just picture pedaling a bicycle. Your leg pushes up and down, but that whole pedal and crank system turns it into the smooth, circular motion that makes the wheel spin. Well, the crankshaft does the exact same thing for the piston. It's the brilliant trick that makes the entire engine work. Okay, so we've met our players, now let's watch the performance. Most car engines run on what's called a four-stroke cycle. Think of it as a super precise, four-step dance that repeats itself thousands of times every single minute. And here they are, the four acts: intake, compression, power, and exhaust. Every single pulse of power your car's engine makes is the result of this exact sequence. So let's break it down step by step. First up is intake, step one of the setup. A tiny valve opens up, and as the piston moves down, it creates a vacuum and just sucks a mix of air and fuel into the cylinder. The engine is literally taking a breath. Next, step two, compression. The valve slams shut, and now the piston moves back up, squeezing that fuel and air mixture into a much, much smaller space. It's like a pressure cooker, and it makes the mixture way more explosive, getting it all ready for the main event. And now, the moment we've all been waiting for, the power stroke. A spark plug fires, igniting that compressed mixture. Boom! The explosion generates this enormous pressure, which slams the piston down. And this is so important. This is the only stroke that actually creates any power. The other three are just the setup and the cleanup for this one incredible moment. And finally, exhaust. This is the cleanup job. An exhaust valve opens up, and as the piston moves up one last time, it shoves all the used-up gases out of the cylinder. It's clearing the stage so the next cycle can start all over again, instantly. And that's the whole symphony. You can actually remember it with a really simple phrase: suck, squeeze, bang, blow. That is the entire four-stroke cycle. The setup, the payoff, the cleanup, all happening in a flash, over and over and over again. Now, that four-stroke cycle is definitely the most common, but it's not the only way to get the job done. There are a few really important variations on this theme, and each one has its own kind of rhythm and its own purpose. The two biggest ones you hear about are gasoline and diesel, and the difference is all about the bang. A gasoline engine needs a spark plug to get things started, but a diesel engine, it creates the bang with no spark at all. It just squeezes the air so hard and so fast that it gets unbelievably hot. Hot enough to make the fuel ignite the second it's sprayed in. So one uses a spark, the other uses pure, raw pressure. We also have two-stroke engines. You find these in things like leaf blowers and chainsaws. They cleverly combine all four steps into just two movements of the piston, which means they get a power stroke for every single turn of the crankshaft. As you can see here, that makes them simpler and lighter, but it also makes them less efficient. That's why they're usually used for smaller jobs. So, why does all this technical stuff matter? Well, because when you understand this simple machine, you're really starting to understand the engine of modern society itself. I mean, think about it. From the cars and trucks that move us and all of our stuff, to the giant ships on the ocean, the trains on the tracks, even the planes in the sky, and the tools that build our cities, the internal combustion engine is, well, it's everywhere. This quote from the source material really puts it all into perspective, doesn't it? The widespread, easy access to mechanical power, delivered mostly by this very engine, is what truly separates our modern world from every other time in history. For well over a century, this elegant little cycle of suck, squeeze, bang, and blow has been the rhythm of progress. It's an incredible testament to human ingenuity. But now, as we're standing on the edge of all sorts of new technologies, it leaves us with a pretty big question to think about. What will be the engine that powers our world for the next 150 years?